signal, known as the Law signal, reached an intensity up to 30 times higher than the usual signals and had a duration of 72 seconds. Its name comes from the note written at that moment by the person who discovered it, Jerry R. Ehman, collaborator and SETI project, a project for the search for extraterrestrial intelligence founded by NASA in 1960. The Law signal is, among all the strange signals received up to now, the one that has the greatest likelihood of having been emitted by intelligent extraterrestrial beings, despite its origin still being uncertain to this day. In a vast universe, 40 billion years old and containing 500 billion galaxies, science is convinced that there must exist, or must have existed, extraterrestrial intelligence. In this vastness, it would seem that there should be fullness of life out there. With this conviction, human beings have searched for it and still search for it incessantly. State-of-the-art radio telescopes track the sky day and night, year after year, in search of any sign of extraterrestrial intelligent life. Nevertheless, in 2009, everything changed. That year, NASA launched the Kepler satellite into space. And thanks to it, we have found thousands of Earth-like planets where conditions for life might be possible. This has meant, undoubtedly, a total revolution in the search for extraterrestrial intelligent life. Given the important advances in astrophysics, some scientists believe that there is a chance of finding extraterrestrial intelligence in the next decades. Seth Shostak, astronomer and director of SETI, Search for Extraterrestrial Intelligence, declared before the House Science Committee of the American Congress that in a couple of decades, we will have found evidence of its existence.
The chances of finding it, I think, are good, and if that happens, it'll happen in the next 20 years, depending on the financing.
A first contact could be close. The question is, do we really want them to find us? What will these forms of life be like? What will their aims be? Is anybody out there? Given the millions of billions of Earth-like planets, life elsewhere in the universe, without a doubt, does exist. In the vastness of the universe, we are not alone. Albert Einstein. 4.5 billion years ago, in the vastness of the universe, the Earth, our home, was formed. From the birth of the universe, it took 14 billion years for human beings to arise, just 6 million years ago. To give us an idea of the time which has passed until our first steps, Carl Sagan made a time comparison in which, if the age of the universe was a year, the Big Bang would have occurred on January 1st. On September 8th, the Sun would have formed. On September 11th, the Earth would have formed. And we would have been born the last day of the year, December 31st, at 11:39. How many things must have happened in other places during the same time?
Today, when we take a look at what we know about the universe and what we know about the origins of life on this planet, it leads us to think that the same things that happened here might well have happened elsewhere. And so life beyond this planet is quite plausible in terms of the science that we know today.
We see the organic building blocks that are essential to life on Earth. And so the raw stuff that's necessary for life is out there. The places that life could live is out there. The big question is, do they come together and form a second Genesis?
We take up a tiny place in the immensity of the universe. the Milky Way, the galaxy we live in, might have around 100 billion stars, among them our sun. In total, it measures around 100,000 light years in diameter.
Maybe there are a million, maybe there are a billion, maybe there are 100 billion planets in the Milky Way galaxy that could support life, the kind of planets that earthly life could survive on. How many of them have cooked up their own life?
Here, from one end of the Milky Way, we, an intelligent civilization, wonder if it's possible that we are alone in all of this vastness.
There's just a lot of real estate, a lot of room for life in space. We've now learned that planets are as common as cheap hotels. They're all over the place. There are 1 trillion, that's 1 million planets just in our own galaxy. If there is no life on any of them, then Earth is a miracle. A miracle. And I'll tell you this, for scientists, believing in miracles is usually not a good strategy.
When we think about how vast the universe is, it would be incredible if there's no other life out there. There are hundreds of billions of stars in our galaxy alone, and there are billions of galaxies in the universe. If life appears on only a minuscule fraction of those planets, then
The Allen Project will become the most powerful instrument in the search for signals from other civilizations in our galaxy. Since it was launched, after just a few months in operation, it has been able to analyze the same amount of area of the universe as in the last 45 years of SETI's existence. Another of SETI's most famous innovative projects is SETI at Home. It was started in 1999 by astronomers at the University of California in Berkeley, and it uses an army of millions of amateur internet users. From home, anyone can be part of this enthralling pursuit. The screensaver analyzes some of the data that comes from the Arecibo Radio Telescope in Puerto Rico. Up to now, more than 5 million people from all over the world have participated and are processing all of the info captured by the Arecibo Radio Telescope. The SETI at Home project has grown so quickly that it is the biggest ever of its kind. Both projects, Allen Telescope Array and SETI at Home, have been a huge advance in the search for intelligent life, giving hope for discoveries in the near future. But undoubtedly, what has radically revolutionized and pushed the search for extraterrestrial intelligent life is the Kepler mission, which is focused on the search for potentially inhabitable planets. It was launched by NASA on March 6, 2009, and orbits the Sun looking for extrasolar Earth-like planets where life may be possible.
Kepler, which is a space-based telescope that was launched about 5 years ago, is on the hunt for planets. Kepler has found literally thousands of planets or planetary candidates. It's a planet-finding machine.
the Kepler spacecraft has been a game changer in the search for other intelligence. Kepler now can tell us which stars have planets around them and which of those stars are Earth-like. That means we now know where we can point our telescopes to look for a twin of Earth.
In 2011, for the first time ever, Kepler provided scientists with a census of the Milky Way. For the first time ever, we can calculate how many stars in the Milky Way could have a planet like ours. Around 1 billion.
So one of the big triumphs of astronomy in the last 2 decades is to show the majority of stars have planets. There are planets all over the place. There are more planets than stars.
According to the data, in the near future, millions of inhabitable planets may be found just in our galaxy.
What Kepler has shown is that maybe 1 in 5 stars has a planet which could have liquid oceans, a bit of an atmosphere. In other words, the kind of place where you might want to build yourself a house, right? So 1 in 5 means that just in our galaxy, there are tens of thousands of millions of cousins of the Earth. That's a lot of real estate.
This data is crucial to answering the question of whether we are alone in the universe and helping us to resolve some unknowns of one of the most famous equations in astrophysics, the Drake equation, which is now of major interest.
The Drake equation is a way to grapple with all of the issues most central to
Get a load of the kid. He thinks we're back in the Clone Wars.
Xbox One X, up to £140 off.
Determining how many civilizations are there out there in our galaxy trying to make contact. The Drake equation looks at 7 independent factors and tries to put a number on each of them.
So you multiply all this up, and you come up with a number that we call N, the number of potentially communicative civilizations in the Milky Way. Our star is the rate at which stars have been born in the Milky Way galaxy over the last few billion years. So it's a number that is stars per year. Our galaxy is 10 billion years old, and early in its history, stars formed at a different rate. All of the F factors are fractions. Each one must be less than or equal to 1. F sub p is the fraction of stars that have planets. N sub e is the average number of habitable planets in any planetary system.